Hi everyone, I know it's been a while since I've recorded a statistics video, but seeing as the college semester is over and I've eaten my own body weight in Taco Bell tonight, I decided it would be a good idea to record at least one more statistics video before I self-destruct from all the Taco Bell I ate. So tonight, we're going to be talking about outliers, and not the Malcolm Gladwell kind. Of course, I do highly suggest that you read Malcolm Gladwell's book Outliers. It's a wonderful story. It's a wonderful book that shows why people succeed in certain situations. But if you're too busy for that, I can understand since you are studying statistics after all, and that is the most interesting thing in the world, right? We're going to just talk about what outliers are in statistics, what they are, and how we identify them. So let's get to it. Now, if I can get my pen here, as you can see, I've updated to the newer version of Office, whatever it is, but whatever. An outlier is a value in a dataset that is either, and I just want you to focus on this definition here, it is 3 standard deviations away from the mean. That means it can be 3 standard deviations above the mean or 3 standard deviations below the mean. But essentially, it's just a data value that is very, very far away from the mean. Alright, so let me show you what that means. Now this is your normal distribution. I'm sure at this point in your statistics class, you've seen this goddamn curve at least 100 times, right? And so I want to point out that right here we have values that are more than 3 standard deviations below the mean, and right here marks where values 3 standard deviations above the mean are. Now take a look at this. The probability of a value occurring that is either less than 3 standard deviations or more than 3 standard deviations away from the mean is overall less than 1%. That's really, 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 really small. And as you know, very large or very small values can ultimately sway, the mean or median of, just the mean of a data set. And that can cause problems when you're doing data analysis sometimes. And so statisticians identify outliers so they can essentially, in some cases, toss them out so they can have a nice cleaner data set that makes more sense. But if you don't want to know all that, the takeaway from this picture is that outliers are far away from the mean, usually at least 3 standard deviations away from it. So let's try a sample problem that might clarify what all this means. So let's take a look at this example. Trisha, the crazy neighborhood rabbit lady, has 100 pet rabbits, definitely a crazy lady, all of which she takes excellent care of, which is good for her. She notices that one of her rabbits named Chunky is kind of fat. Specifically, he weighs 35 pounds, while the rest of the rabbits weigh 5 or 7 pounds. After selecting a sample of rabbits, she finds the sample's mean to be 8 pounds, with a standard deviation of 5 pounds. Based on this information, should Chunky the bunny be considered an outlier? Now, intuition tells us yes, that Chunky the bunny is morbidly obese and is probably not representative of usual rabbits, and his weight is probably 3 standard deviations away from the mean. Now, technically, since this is a sample, we're going to... Oh, hang on. Now, technically, since this is a sample, you would use a slightly different formula than what I'm about to show you. But the general Z-score formula will show you whether or not something is an outlier or not. So let's try it, right? Go on. Anyways, to determine if something's an outlier, calculate the Z-score, which I'm sure you've done a billion times before, and interpret the result. And like I said, outliers have a Z-score that are greater than 3. And I should mention that this can be treated as absolute value. I know, my penmanship is terrible. I should invest in a Wacom tablet, but I'm broke. It's life of the college student. Come on, deal with it. Yes, absolute value. So if it's less than -3, so -4, -5, -6, and yada yada yada, or greater than +3, 3, 4, 5, 6, 7, 8, 9, 10, yada yada yada, then it's an outlier. So let's try it, right? Here's our Z-score formula, your observed data value, right? Subtracted from your mean or sample mean, divided by the standard deviation of your sample or population. Alright, so moving on. So let's try this. Well, Chunky the bunny weighed 35 pounds. This is our observed data point, right? 35 pounds. We're going to subtract it from our sample mean, our sample mean, which is 8 pounds. And we're going to divide it all by our standard deviation of 5 pounds, right? And what Z-score does this get us? 5.4, which is much greater than 3, right? And so, ta-da! It's an outlier, and we know outliers are more than 3 standard deviations away from the mean. Now, obviously, 5.4 is greater than 3, so we can conclude Chunky the Bunny is an outlier. And of course, if I was doing statistical analysis on this crazy woman's on the weights of these crazy women's bunnies, then I would probably not include Chunky in the data set in order to make sure that my mean or any of my other statistics are not highly skewed. Alright, so that concludes, I guess, the first discussion on outliers. The next video, we'll talk about the alternate discussion for an outlier. Now, if you excuse me, I'm about to go explode from all the Taco Bell I've eaten. So, thanks for watching!